Hello and welcome everyone to whoever's listening to this podcast. I am Shah. I'm a PhD student at Arizona State University, and I create these podcasts where I invite young machine learning engineers and researchers to talk more about what they are working on and share their insights on how to get started in these domains. And for this particular podcast, I have with us Sara, who is a research scholar at the Google Brain team. And she has an amazing journey of how she got started into the machine learning domain and how she made the transition from pretty much a non technical domain like economics, and also is now working into a deeper aspects of machine learning like interpretability and other research works. So, welcome, Sarah. It's really nice to have you.
Yeah, lovely to be here. And I will say a little cheeky aside that economics is not entirely non-technical. It just uses far less complex models, but but we can debate about that when we get to it.
Yeah. I mean, what I meant was like something like making the transition from purely statistical perspective to love, like you're working on
Yeah,
interpretability, which is like at the core of machine learning research. It's something
yeah.
really
It's
highly
very
researched.
different. It's a different ball game. Yeah.
Yeah. That's really nice. I personally admire that particular transition. So, awesome. Before I get started, I'll quickly go over a few of the key points for people who are listening to this podcast of what we'll be talking about. We'll be talking about how Sarah got started into machine learning. She's much more of a self-taught machine learning expert, and right now she's working with some of the big heads in machine learning research at Google Brain Team, which is really nice. So we'll be talking about how she made the transition from a non-technical a bit non-technical domain like economics and into the machine learning research, and will be later on much more focused on the understanding what interpretability really means and what does it really stand into the industry, and why is it something not much more of a desired aspect but much more of a required aspect. So, coming to the first question, Sarah, can you tell us a bit about your workspace routine over here? Like, what are you currently working on at the Brain team?
So right now I'm working on this interesting problem of how different desirable properties contradict each other. So in an ideal world, we want to train models that are everything, that are high performance, that are interpretable, that are fair, that are robust, that are compact, that run at the edge, that are accessible, that are cheap to train. And the list goes on. And the tricky part is that most of recent computer science history has focused on high performance, mainly because we didn't even have high performance. So for a lot of history, we just wanted to get good. We didn't even care how we got there. And now a lot of perspective has shifted to, well, we have models that are good. What about this whole other list of things that we would love to have? And a lot of my recent work is figuring out when we optimize for one thing, do we compromise others? So most recently, I worked on a series of papers with my colleagues that essentially looked at compression. And as you compress, and when we talk about compression, normally we talk about removing weights from a network. And typically this is to deploy easily. But when you compress, often you give up other things. Like we showed that it amplifies bias. So things like this, how do we understand the trade-offs that we incur when we design models are really interesting to me. And also really important for how do we deploy models in the wild so that they perform well, not just in our beautiful sandbox of we've got our training data, but also perform well once we've deployed and we're dealing with new data that was unseen during training.
Wow, yeah, that's it seems quite a sounds at least a lot of bit of interesting, but yeah, we'll be talking about that interpretability in the later part of the podcast. But before we move on over there, one of the most popular question I had to ask this was like, uh, how did you make your transition from economics? I mean, if most of the people who are working into the deep research aspects, they often tend to have a master's or a PhD and a much more of an academic industry or academic or industry experience into computer science domains. But coming from an economics background, and I have seen your profile over the time, and also your the very nice article that you have written over there, how you made the transition. It doesn't really speak a lot about, but the phase is long enough. I mean, it wasn't easy for you to make the transition. So can you talk about how was your journey into getting started into machine learning on your own? What were some of the things that really worked the best for you, or some things that didn't really work nice enough, how the internet might say the otherwise?
Yeah, those are very, very good questions. I mean, where do we start? So maybe I'll tell people a little bit about my background, and then we can talk about what worked and what we didn't work. So, like you described, I started out in economics mainly because I loved economics. I grew up in Africa, so economics was one of the most technical fields that I could see on day to day. A lot of the people that I saw that were technical were from the World Bank or the IMF. And I thought this is a very interesting way to model the world. So a lot of the reasons why I fell in love with economics and I wanted to be an economist for the World Bank were because I wanted to be able to quantify the world around me. So after I graduated, my undergraduate degree was in economics. I actually came out to work in economic consulting, in particular for antitrust cases, for the FDA and the FTC. And this is almost like a dream for an economist because you get experience working on real world cases and you use economics. But at the same time, what was interesting is I was spending my weekends volunteering. So I started a nonprofit and I was working with nonprofits from where I'd grown up. So from areas of the world that I'd grown up in Africa. And there were two things that happened. One is that economic tools favor statistics, as you described. So the models tend to be simple, linear regression models, and you tend to impose a lot of assumptions about the distribution of the data. The tricky thing is that with real world data, often you have to make so many assumptions to make it work for the linear model that the model just strains. It doesn't end up being a good reflection of what new data you'll encounter. So one of the first things that happened is I started realizing there were more complex ways of modeling the world that were very fun. And that was the first turning point. And after I realized that, I just wanted to learn more. And I also wanted to have more control end to end because I didn't want to just be doing the algorithm phase. I wanted to be doing the end to end deployment. So that's when I joined Udemy. And I consider that to be a really, really amazing chapter in my career because I joined Udemy when it was a startup. So I was part of, and it still is, but it's larger now. And Udemy at the time was just over, I think it was like 140 people, but the data team was very small. So the data team, I was part of the first people on the data team, and the modeling opportunities I had were super exciting. So that was what I would describe as the brute force stage of my career, where a lot of days I would be studying coding before, working all day, and then going to night classes in coding. And I think that after being at Udemy for 2 years, I realized I had learned so much I wanted to teach. So I paired it with teaching. So I was teaching machine learning. And that's when I actually relocated to Kenya to teach machine learning. And then at that point, I got an offer from Google to join the brain residency program, which was also very unusual at the time. This whole brain residency, I was part of the second cohort. And at the time, I thought this is a very interesting opportunity to try research because I had worked on all these applied problems. So I think in many ways, even though my journey seems like a zigzag, it was always motivated by problems that I was curious about. And also, it was always motivated by a desire to model the world with data. So even from economics to what I do now, the underlying mechanism and question is still the same. It's more that the tools have changed, and that's what has really changed. And also, the degree of end-to-end control of the tooling has changed because when you're doing research, you do a lot of large-scale experiments, and you're much more technically deep.
Wow, that's quite of an interesting journey. But yeah, okay. So I get asked this question a lot in most of the comments over here. Is there are two types of people who are getting really interested into machine learning. Either it's the first kind of people as graduate students or undergraduate students who want to learn machine learning, but of course they wanna skip all the boring mathematics and calculus because it doesn't really expedite the process into getting started. And the second kind of people are who are already into the software development world, who are working on other aspects, but they want to jump to machine learning aspects. So how, what would be a tip and advice from you? I mean, you explained yourself, you worked on a pretty much of a hands-on projects, you taught a lot. It was more like you were learning and you were teaching, so it kind of built on a very strong base. But from your perspective of getting started into machine learning on your own, how, what tips would you give to them? Like, should they go for courses online? Should they just get their hands dirty with some kind of projects, or should they
Yeah.
focus on some of the core aspects? Because hey, core aspects really matter a lot. Something like that. What would be your perspective?
I would suggest a few things. I think, firstly, congrats to the people who want to get started. That's the hardest step, is like articulating that you want to grow and grow within a discipline. The first thing to recognize is that machine learning is a craft like any other. So for you to excel at machine learning and be at the frontier of a field, you have to treat it like a craft and have to understand that it's not overnight. In fact, I would say that, like most crafts, it takes upwards of 4 years to master. And so be realistic about what is your current ability to integrate this into your life. Can you take classes, or are you already working and do you need to do this in the evening? And your goal should be, as soon as possible, that this is something you're doing for most of the day, because that's when you really see those jumps in your command of a discipline, is when you can allocate a lot of time to it. And so that might mean, for someone who's working, can you siphon off an opportunity, or can you do like a part-time research collaboration? So something that's not well known about researchers at Google is that often, if you email them and you want to collaborate on research, often you can, because researchers can collaborate externally. So things like that. So seek out the opportunities to start building the momentum towards you can make something a full-time realization. The second thing is, I personally am not a fan of courses. I think that there's a tendency when you're doing courses to enroll in many and complete none. Having worked at Udemy, and I really believe in online education, but what I found is that online education can be quite aspirational. It's like the gym. We tell ourselves we're going to go, we sign up, and then it's not clear, like, do we actually put in the work? I think it's much more important to complete a narrow set of resources. And I do think theory is important. Like I said, my background is statistics, my background is econometrics. So for me, it was more that I was trying to connect those disciplines to deep learning theory. And for that, I would recommend the deep learning textbook, or the elements of statistics, but just choose one and complete it. Don't fudge around and like do different resources, because I think that's when you start to lose momentum. Or the most dangerous thing is that when you're doing something by yourself, it can feel quite lonely, and you can just feel overwhelmed by the amount of resources. You mentioned projects. Projects are very important, but it's much more important to do projects with people who are better than you. So really, doing a Kaggle competition is fine, but you're going to get the most benefit from choosing something which also speaks to what you eventually want to do, and also speaks to your interests as a person. So often I think the nonprofit space is really powerful in this sense, because often a lot of my students are working on projects which are personally close to them. So one of my students now in Nigeria is working on low resource languages, because their language is low resource, but they're coming up with all these insights which wouldn't be possible for someone who didn't speak the language, who couldn't inspect the underlying data. So things like that. Think about what is your relative edge, and lean into that. The final thing I'll say is that everything is a combination of ability and luck. So there's only so much you can do and do within that. But the actual biggest ingredient, beyond all that sunk time preparing beyond doing the projects is mental strength, because I think that mental strength is very important, particularly when you enter a new discipline. You have to have the endurance to persevere beyond the initial discomfort, but also beyond the set of failures that are inevitable, right? I think that most people trying to get somewhere fail a lot along the way. And you have to have a sense of yourself and who you are beyond this individual challenge. Because if you don't have a sense of self, it doesn't matter. My colleagues, a lot of them are very smart people, but I think that dominant characteristic is perseverance and passion. Like they care a lot about what they do.
Yeah, definitely. That's a valuable piece of advice, because yeah, I feel that's highly relevant, because most of the work in research, it's mostly the people who are doing that research are highly motivated to do that, regardless of whatever the end gratification factors are involved. So I guess yeah, that's really the understanding the intrinsic motivation is really key. So yeah, that's a valuable piece of advice. Um, and can you talk about like what was your role as a resident at Google? Like what projects did you get to work on over there, and how did that build up your expertise or knowledge in machine learning? Uh, how did you use that program to maybe pivot your efforts into the machine learning space?
Yeah, I mean, so I think the residency is a fantastic opportunity because at the time there would be no other way for me to do research. I was already in an industry applied lane. I wasn't planning to do a PhD. I mean, for me, this was my chance to sample research. And if not, I just wouldn't have done research. So it really was I think, at least in my case, definitely the purpose of what the residency was meant to do. That being said, when I arrived, I realized that many of my colleagues already had PhDs and were in the residency program. So I think that there's this tricky thing where the people who ended up in the residency ended up some being very almost overqualified for the residency. So I would say um, it it was a very intense year. And the reason I say that is that there was a momentum because you had all this access to all these resources that also came with responsibility. Like you feel like the sense that now I need to produce something, like I need to do research. And I think that often years like that are very good for crystallizing and creating momentum around projects. But they're very stressful years. So I would say the residency for me was a very stressful year. I definitely recommend it to anyone. But I think part of what made it stressful in my case was that my cohort a lot of them already had PhDs. So I've since advocated internally that we need to be doing more to actually have more people who don't have PhDs, who are diverse in different ways. Because otherwise it ends up a little bit like you are just swimming up this current and all these people already have all these papers that they were developing during that PhD and are now pivoting. But that being said, the beauty of something like the residency is that you get to determine your research agenda. So you asked what I worked on. I mean, I could choose what I wanted to work on. And more than that, I could also do multiple projects in a year. So I chose interpretability, which was very much rooted in my desire to understand more about machine learning. But I also got to choose and experience many different collaborations, which is amazing. And it's still a freedom that is part of being a researcher, where you get to work with many different people and experience different collaborations. And how did it relate to the rest of my experience at Google? I decided I loved research. I mean, I think I'm spoiled because I love both applied problems as well as research. But it gave me there were a few things that I liked. It allowed me to connect back to my joy in teaching. So I spent residency doing a lot of research, but I also went back to Africa to teach. And last year I was part of the new Ghana lab AI in Africa. So we just opened a new lab there, and I helped set it up. And then the other aspect of it is that with research, a lot of what you're doing is mentoring other people with research. So I've really enjoyed collaborating widely and collaborating with people who are not just within Google, but outside Google. And that's not really possible within an applied setting, because often you have questions of IP, and you're not able to publish everything. And that's the beauty of working in research, is that you get to publish and share things open source.
Yeah, that's quite interesting. And talking about the like, I'll just jump into the interpretability just after this question. I've always wondered, what does a day look like in the life of a researcher at Google Brain Team? Because like, what do you get to work on? Because most of the work tasks for software developers, like at least in the computer science domain, we know that they have a certain set of deliverables of fixing any bugs or fixing any features that they work on. But what do you what are the deliverables for a researcher at Google Brain Team? Like, is it something getting the accuracies right for a particular data set, or cleaning the data sets? What are the monthly assignments for a researcher at Google Brain Team?
So I think the first thing, and perhaps the hardest thing, is that it's no monthly assignment. So our time horizons are much longer, and we often set them. So a lot of the difficulty is in deciding what types of problems are worth working on. And often you do a few things. So you have people who you're mentoring, and so you'll have weekly meetings with them because they're working on projects which are really interesting, and so you're helping guide those projects. You'll have your own research agenda, and so a lot of that is, oh, I have this question I'm looking at right now, so you'll be launching large-scale experiments, and so there's a heavy engineering component where you're checking in code, you're launching experiments, typically at scale, because a lot of the beauty of Google is being able to leverage compute to explore some of these questions. And then also you're trying to engage with new research. So for example, I'm like, I wonder if you can see the massive pile of papers on my desk, but there's almost too many ideas. And so you're trying to figure out what ideas are relevant to be aware of. But you're also engaging with other researchers. So I would say it's similar to an academic PhD environment, but in many ways, you do have the benefits of having these resources to conduct your experiments, as well as you tend to be able to engage with product as well if you want to. So some researchers do connect with product more and do deploy their research ideas into product. And that's more typical of wider research. So I'm in a pure research team, but if you're in a wider research team, then you'll probably be placed closer to product, and you'll be thinking about, like, how can I innovate with respect to this product?
Wow, wow, that's quite interesting. And this actually brings me to a different question. And sorry to before I jump to interpretabilities, what do the projects over here at the Google Brain Team are driven by, say, exploring the research questions more, or are they focused more on fixing a product or maybe building a product? So what drives these assignments for you? Are they towards a like, if do you does the Google team firstly have a product in mind that they want to work on, and hence the research question that comes to you, or is it just exploring these research questions and solving them?
Exploring these research questions and solving them. The truth is, both are fun. So there are other research teams which are centered on products. So research AI is big, and within research AI, there's many different teams. But even within Brain, if you want to work on a product, you can work on a product. But if you want to work on a research problem which isn't directly linked to a product, then you're also free to do so, because what Brain has found is that in the past, efforts which were not linked to product at all ended up having a huge impact on product, and ended up being widely used and deployed. And so the goal is to have a small fraction of researchers working on things which are similar to moonshots. They're bets that this idea doesn't have any clear link today, but it can help inform how we do all these things tomorrow. And that's the beauty of technology, but it's also why it's quite rare. There's only a few places in the world that you can do this. So it's a really unique place to do research because of this. You have so much freedom to help shape a research agenda and to help think through at a long time frame, well, what questions are worth thinking about, and how should we also make sure that whatever we do is open source and available to everyone to access. So all my code, all my papers, all my research is available to everyone. There's nothing, there's no secret. And that's another beautiful thing about Brain, which is less possible if you work on product. Because when you work on product, you gain a lot of really interesting things like massive data sets, really interesting problems, but you do have to be more cautious about how you share innovation.
Yeah, yeah, that's true. That's true. And jumping to the interpretability domain is something I since I started my PhD, I'm much more inclined towards building interpretable models for the healthcare domain, because most of the projects, at least three of the projects that I'm working on, are use data sets from places like NIH and Alzheimer's disease institutes, and most of these companies, or I wouldn't say companies, but organizations, are really concerned into building and making much more reliable use of AI. So I wanted to, that was one of the reasons I reached out to you for this podcast, is to understand interpretability from a much more broader aspect, but also a much more narrowed down aspect as well. So my
Oh, let's do both.
so my first question. Yeah, I promise I won't go too much deep so that it doesn't feel like a
No,
pitfall
please
for.
do. That's fun.
So from a very surface level perspective, we most of the researchers do ask that interpretability is something really nice to have, but from a person who has been working in this domain, can you talk more about why this interpretability is not something as a desired feature, but much more of a required feature? Because most of the people still see that, okay, I mean, if neural nets are working fine, if they are giving me the values, why shouldn't I use them? But most of the people working in interpretability might debate the otherwise, right? Like, it's much more to just explaining a model, it's much more to mitigating biases and all those things. But you, as a person who has been into this domain since a long time, can you talk more about, like, why is it much of a required aspect of deep learning?
It depends. So, I think that sometimes it is a nice to have, and sometimes it's required, and it's a spectrum. It's like any type of desirable feature. Sometimes you're okay with reasonable tested accuracy. Other times you need high tested accuracy because it's a very sensitive classifier, and you wouldn't want the classifier to go wrong. An example of where we might be more comfortable with less interpretability is if, for example, we have a system which recommends what DVD to watch tonight. So you can imagine a recommender system. And okay, it might go wrong, and you might be annoyed that it's recommending a different genre, but it's not life or death. So there we may place less emphasis on interpretability, particularly also if we have a long historical data set and we have a good understanding of what are the weaknesses of the model and the strengths of the model just from observing input output. Where we care a lot is where we don't have much data longitudinally. So we don't know how the model performs upon deployment. We don't have a lot of historical data, but also the stakes are very high. So you mentioned healthcare. So this is most salient in healthcare because healthcare often interpreting model behavior in an incorrect way can really harm human welfare. But it's also true of other sensitive domains like self-driving cars, like credit scoring, anywhere where an incorrect prediction harms human welfare to a large extent, we care about knowing what the model behavior is. So I think that your other question was, wait, what was it? There was a second question at the end.
So it's more like, understand, like, I have seen this question stems from the I don't know if you watched this debate. I forgot which year it was. It was a NIPS conference where it was a
Oh
friendly
yes, it was Jan. It was Jan LeCun, right?
Jan LeCun versus I forgot his name. I remember his
Rich,
Rich Caruana.
Rich. Yeah,
Yeah,
he's
from
at
Microsoft.
Microsoft.
Yeah,
So he's also fantastic. All his papers. He's the early decision trees guy.
yeah,
Yeah, early case based reasoning.
yeah. And although it was a friendly debate, but I really liked Jan's points on why, like, of course, I know he was actually jokingly meant that interpretability is not something highly desired, but from a person who is working into interpretability with a very close aspect is, I want to understand why it's needed. Like, I mean, of course, like you mentioned like recommendation from Netflix doesn't require an interpretability, but still it requires much more of research to understand and explore interpretability, right? So that's what I want to understand
Yeah.
from you. Yeah.
And I think that you are correct that if interpretability was cheap, we would want it for all cases, right? It's almost like we want the perfect model. So ideally, we would have interpretability for everything. Where we place more emphasis on it now is for high impact cases. I would also say one of the biggest obstacles in interpretability right now is a translation problem from theory to toolkit. Right now, toolkits for interpretability are actually a non-trivial problem. So we have all this research about different techniques and how to incorporate them into your model, but efficient tooling, which does this in a sensible way that practitioners can just use, is limited. This is why Lime remains so popular, is that Lime invested in toolkits. So everyone who uses interpretability uses Lime. That doesn't mean Lime is the right method for everything. In fact, many papers have shown Lime has its strengths, it has its limitations. But the reason why it's so widespread is a software issue. It's that Lime actually has software which is easy to use. So I think that in terms of thinking about the gap right now in how we think about ease of use for different use cases and why we emphasize so much high risk use cases is because it's actually quite hard for a practitioner right now to think about interpretability in an easy way that slots into their current training regime. Recent work that I did with my collaborator is around this. How can we use the existing training regime of a model and take the checkpoints that are already stored over training and use that to surface what examples are most challenging so that someone looks at them and can understand what their model did good at and bad at. And the beauty of that type of framework is that it's already a framework that practitioners are doing. So they're already training a model and it fits into that. And then at the end, they automatically get an interpretability tool. But right now, that is where most approaches are structured as, okay, you've trained your model. Now you're about to deploy it. Now here's a checklist. You have to do interpretability. And that's not the ideal case. The ideal case is that interpretability and the toolkit is so seamless that you want it every part of your training. You want to understand how your training happened. You want to understand what was challenging at the end. And it's easy for you to do. Not that you see it as this dreaded thing that you need to check for before you deploy a model.
Right. That's quite interesting. And just to dig more on one of the things that you mentioned is most of the practitioners find it difficult to understand what interpretability means is, and that is one question I also wanted to ask is, is there a technical definition of interpretability out there? Like, how do we define interpretability? By, I mean, most of the machine learning models that were like when it started, we have a metric that can measure, right? Like for medical applications, it's the sensitivity or specificity and all those metrics. Is there a metric that can really say that this model is better interpretable than the other interpretable model, or is there a metric where we can weigh which model is better at interpretability than the other? Is there a metric out there for that?
No, and there shouldn't be. If we think about it, like interpretability really means codifying tools to gain intuition. And intuition really depends not only on the beholder. So your sense of intuition is very task dependent, but it's also based upon you as a person and your relation to the task. I, as a researcher, may need a different set of tools than someone who's an end consumer. So it's very hard to say there's a single metric. What we do want is we want interpretability tools to be meaningful, meaning that they do provide intuition. A human can come away with intuition, an increase in intuition about the problem. And critically, we want them to be reliable. So a lot of my early research was, how do we measure reliability? Because if we're not even being reliable, then what are we doing here? Because an unreliable interpretability method can compound a problem. If you have an unreliable interpretability method of a model, and then the person makes an incorrect decision based upon that interpretation, it can be just as dangerous as having a black box model, if not more. So these two dimensions, it is very important that we have different ways of measuring progress. And my research on the reliability has centered on, how do we actually articulate what is a failure point? Because for interpretability, it's not clear that we're ever going to say we've arrived, sign off. This is interpretable now. But it is clear when fidelity breaks. The absence of fidelity is an important thing to measure, because that way we can anticipate what types of design choices and interpretability tools can cause these breaks or failures. So I was involved in a series of papers in that with my colleagues, where we showed that many commonly used methods have these unintended failure points. And I think that helps influence iterative progress. On the meaningful side, I think this is an area that we need to work on more as computer scientists, because what we don't do very often is human studies. And I'm glad to see that more human studies coming out of interpretability work. And there, the question is, how do we measure meaningful? And I think that some of the most interesting recent work has been asking, what contributes more to trust? If you were to present the confidence of a prediction and then a saliency map, what does a human end up trusting more? Are the tools that we're designing actually furthering the objective that we have? And in my recent work, I've actually moved away from saliency maps, because I think it's much more useful for humans to have a subset of examples that are much more challenging, rather than a single explanation, because then you understand the relative importance of what the model finds more relatively challenging. So you show the hardest examples to the model, and then you show the easiest. You get a range of scores.
Wow, that's quite interesting. So would you say that designing an interpretable model is specific to each and every application that uses deep learning or machine learning models, and it varies from the data set and the users that are interacting with the model? Would you say that?
So that was a very good question. My goal as a researcher is not to design tools that are that specific, because if that were the case, then I may as well work on industry. So there has to be an element of generalization. So while there are probably types of tools that work better for certain people, so for example, you're a researcher, for you, it will perhaps be more interesting always to understand the distribution of data rather than an individual example. For an end consumer, they always want to see their example. Why did the model make prediction for my example? So these are different use cases. And there will naturally be some differences in tooling that are specific to those use cases. But we can still generalize beyond very specific problems, because in many ways, a lot of what we want in terms of intuition ends up being the same. Like what we want to do often is to audit the model by understanding what the model finds most challenging. We want to do this in a tractable way. We don't want to look at all the examples in a training set. We want to look at the relative. So we want to look at the most challenging. And then the second thing is that often the tasks that we look at share common structures. So for computer vision problems, there's common properties of what we would an explanation tool to have. For natural language tasks is common, and that those can generalize more. You will typically see, and I think this is getting better now, is that we're designing interpretability methods that are specific to NLP, that are specific to computer vision, and that should be the case, because these are very different ways of structuring data, and they need different toolkits.
Yeah, that quite makes sense. Yeah, definitely. And would you say this question comes from a researcher's perspective, or maybe a newbie like me who is still doing all these kind of literature surveys of understanding what interpretability means? I see a quite of an overlap of the terms explainable AI versus interpretable AI. And to my understanding is to a person who is not into the computer science space, how do I explain what is the difference between them? Because I see a totally different set of algorithms or an approach to explainability in AI or machine learning models versus a complete different approach to interpretability. But from a subjective definition, they are trying to solve a similar problem, right?
Yeah.
They're trying to make these models interact better with the users so that they have a better trust. So it seems like they are trying to reach to a same point, but through two different methods. So what is your take on that? Like, I might be wrong, so please
No,
correct me.
you're right. I mean, I think you're right. And you're right to say it's not clear that we should care about the difference. I mean, okay, so just to give context to the audience, explainable AI is essentially not an explanation. So for your prediction, I'm going to give you an explanation of why this happened. So it's normally instance based. So you have a single instance and you'll create an explanation for that. Interpretability methods are this broader set of tools like t-SNE or visualization tools, which are much more about understanding, for example, the embedding space and distance between different terms, or, for example, the work I mentioned, which looks at a subset that's more challenging. That's no longer a single explanation. That's more giving you a sense of the distribution. Um, which one to focus on, which one's worthwhile? I think the goal is the same, to provide intuition. And in some ways, the distinction feels perhaps unnecessary. But I can understand why some researchers prefer it, because the end user may be different. Again, explanation-based methods tend to be motivated by the idea of an end consumer or end patient, a single person who wants to know for their example. Whereas these other methods tend to be motivated by there may be, you may be ordering a model before deployment, so you don't want to look at every example. You want to like have a sense of distribution, and that's a different use case. So that's perhaps why that might be useful. But I wouldn't. I think to everyone out there who's like looking it up right now, I wouldn't fuss about it. Like I think I think the more important thing is to gain a sense of the different types of tools that are available, and then to think about what piques your interest. Where do you think you can contribute to this field?
Right, right. Yeah, and yeah, talking about like people who might be interested and who might be searching on these things, what would you say would be the best state of art for interpretable models? I mean, for AI, I know a few of the methods, but please add to that list is I know a few of the models like Lime, of course. Lime is something that has been a favorite throughout all of the researchers. There are game theoretic models like Shapley value based, like tree Shap, kernel Shap. They have also been really popular and used in real world settings. What do you think other or any upcoming works that you and I might not know of is would serve as a good state of art techniques for building interpretable models?
So that's I guess, it's a little bit of a trick question, because state of art implies that there's a way to compare, and there currently isn't. Because of everything we just talked about, it will very much depend on what is meaningful for the task. Also, is this method reliable? What I will say is this: I think Lime and Shapley values are very computationally expensive to compute unless you make certain
Assumptions.
assumptions. Exactly. So I would say that in many ways, I think clever engineering there will also be important if we can create packages which make it cheaper to compute Shapley values. And this is where, again, I see a real role for engineering to come into interpretability field and take some of these great theoretic contributions and translate that to tooling which works. So Lime, again, the reason why it's spoken about by everyone is not because it's so much more fabulous than other methods. It is. The authors wrote a fantastic paper, but there are other fantastic papers. It's because the authors also invested in software and made it easy to use. And so we have to remember more in terms of what is interesting in interpretability is that we need to remember more who our end users are. Who is this for? And articulating all these nice theoretic properties is fine, but we also need to connect it to what is the user experience when they use these tools. And is it useful? Because, again, if someone is relying more on the probability than they are the saliency map, then why do we have the saliency map?
Yeah, Yeah, that's okay. Yeah, I guess, yeah, that question was much more of a subjective. Let me ask you a much more like, I can, if I can rephrase that question to get much more of an information from you, would be uh, if I were to suggest someone to get started in a computer vision domain, I would definitely say him or her that, hey, please learn convolution neural networks, because we see most of these models, or most of the other models that have been built on top was on the basic architecture of CNNs. And for people who are interested in NLP, transformers played a big role into defining the most of the latest architectures in NLP models. What would you say would be a building block of interpretable models, if there is any? I mean, correct. Feel free to say that there is no building block, but do you see a common building block that is present, or at least a common approach that one should at least look at while trying to design an interpretable model? That, for example, saliency maps,
Yeah.
it was something that provided people a sense of trust, or a sense of um, explainability to people who were
Yeah,
trying to build that
I
model.
mean, I think you're saying a different point, which is what is important to be aware of. And yes, saliency maps is one of them. A lot of work is focused on saliency maps. So to ignore saliency maps is ignoring a lot of the work to date on interpretability. Visualization tools is another. So TSNE, embedding visualization tools, and then also global importance rankings. So things that assign scores to all the images and tries to rank global feature importance are important. But also, I think that in the process of learning about these subfields, the most important thing is to also form an assumption about where, how, and when they should be used and where they should not be used. Saliency maps are a great example of that, because saliency maps, uh, perhaps for certain settings where you want an explanation for your data point, are useful. But there are many limitations to saliency maps, such as reliability issues, and also the fact that they don't give you a good sense of global importance. They don't give you a sense of, if you look at one saliency map, how do you know it's bad or good? Do you have to
Yeah.
look at others to know? um, so these are really, I think that this is what makes this field exciting for people right now, is that there's so many open questions. And in many ways, this field is much harder than other subfields because there's not a clear way to measure progress. It's not like optimizing for soda. You are codifying a preference. And that makes it a very challenge technically and also theoretically.
Right. Yeah. Definitely. And yeah, I guess the reason, I guess, would you comment that achieving interpretability might serve as a bottleneck for uh, the wide range use of deep learning in the practical aspects? Would it have any bottlenecks to use of deep learning models in much more general use in the crowd?
So I think if interpretability tools improve and become more efficient, it can actually unlock a lot of new innovation in deep learning. The reason I say this is that the first interpretability tools were actually used by the first saliency maps actually were used by deep learning researchers wanting to debug their models. And if we can provide valuable interpretability tools that fit into a typical training regime, that are not all this extra at the end, you have to add all these things, it will unlock a lot of intuition that's really going to help guide how we develop our models, how we audit them, and how we deploy them safely. So I actually see it as a catalyst if we do it well.
Yeah, yeah, I definitely agree, because that was one of the key things that really got me interested into interpretability, because I read this somewhere, and I don't know if or it was a talk was where people said that not only interpretability might be useful for the people to get better understanding of what the model is behaving like, but it would be also a debugging tool for people or researchers or developers who are working on it. And I was like, yeah, that's, I never looked interpretably in that particular aspect. It's going to serve as a much more transparency window that would be useful for users and students. So yes, definitely on that. And uh, just one last question on this particular topic is, how do you see interpretable at least the next milestone in interpretability domain? Because most of the models that I have seen, or at least the papers that I have read, interpretable models are like these sidekick models of the original deep learning model, right? Like
Yeah,
they're
well
like
put. I
yeah,
love that phrase.
they're like the wingman models for the original model.
Yeah, yeah. Wow, these are excellent. I'm going to keep some of these.
Yeah, that's what I have been, and like I have at least seen they are in the real use, where the original model is doing all the beautiful work, and there is this one guy who would be commuting
Yeah.
back and forth trying to explain and making justifications for that particular model. So do you see this, do you see the future of interpretable models in a very similar, on a very similar line, or do you see in the future, if significant research is being done, it would stand alone? Interpretable models could be a standalone model or a new architecture that can redesign the existing versions of, let's say, CNNs or transformers, of how they look like right now. Would Do you see that path or direction of research may be converging to, or do you see just improvements on that psychic versions of models?
Yeah. So I think it's very exciting. The secondary, really, what you're talking about is this following pattern where a lot of interpretability is after training and is treated like we're done training. Now we're going to do all these acrobatics to try and make this model that we optimize for without interpretability now become interpretable. And you're correctly pointing out that this is a lot of extra work, right? It's like it's like the person doesn't go to the gym. We just task a friend with somehow magically putting an outfit on them that makes them look like they went to the gym. It's
Yeah.
always easier if the person just goes to the gym. So that's the point of how do we explicitly optimize for interpretability. The difficulty I sense with that direction is going to be is that it will entail most likely a trade-off with accuracy. So, but that's also good, I think, because I think it will force us to articulate what is our desired trade-off. And right now, although we don't see a trade-off with accuracy, we're making all these assumptions and these post hoc methods that are affecting reliability. But if you bake something in, you ensure reliability. So it's another benefit of just the person going to the gym. They really are looking like they say they look. It's not just really great design clothes. So I think that this is really the challenge and the most interesting open problem in interpretability. Can we think about what constraints we can add to a model? And those are likely to be different for different domains, because if you think about computer vision, we have a certain perceptual range that we can absorb inputs in. If you think about language, we read in a certain way. So can we impose some of the ways that we actually can absorb meaningful information and codify that so that we have a useful representation, but it also makes sense? So very excellent question, and I love the phrase psychic. It's true.
Yeah, that's what, like, being on the pro side of interpretability, you definitely feel sympathy for interpretable models. So yeah, that's what I feel. But yeah, that's a very interesting, like, I love how you put it in the very last line. Says a great it has a great deal of hopes, but definitely it's not definitely going to redesign the whole architecture, but somewhere along those lines. So I really love that optimism. And just to conclude for this particular podcast and deviating a bit away from the interpretability aspect is, I might be asking this question again, but I'm looking for an, like, what would be an overarching definition from, or advice from you, for people who want to get started? Because the reason I'm asking this question again is, even though people who have been into the pro computer science domain, they find it difficult to um, find projects, find what's interesting to them, because people who are still exploring machine learning domain, it seems really cool. You can definitely get started onto projects and use some of the existing projects that are outside on the internet and get inspired from that, but the actual amount of research and creating something novel still remains a lot of challenge, mathematically and also from an implementation perspective, because programming and coding for a machine learning aspect is not really easy. I mean, it takes time, it takes a lot of effort. So in terms of resources or the tools that you might have used, what would be what really worked I mean, you did answer that working on those real world projects and teaching them back really worked for you, but apart from that, did you use any, what was your method of, or right now, what is your method of getting updated to the recent developments into any of the research topics? Or how did you back then prefer to practice your coding skills, your programming skills, and how did you keep up with, like, what was your um, routine or best practice for that?
A few things. For coding, definitely hands-on projects are far better. It's the best way to accelerate because you have intermediate goals, and it's the best way to force yourself to learn. It also narrows the field. You're not trying to do everything at once. Of course, this is different from optimizing for a Google interview standard, which requires just like a certain subset of types of problems. But I think that initially, your main goal should just be gaining experience going through a problem. I think about the window dressing of optimizing for interviews and stuff like that subsequently, because what will get you an interview is showing the passion and executing on a problem and getting started. And this will also show you the complexities of a task. The other thing, very important, work with people who are better than you. I cannot emphasize it enough. All the biggest turning points in my own growth have been from working with people who are far better than myself. And particularly early on in your career, it's very critical to work in healthy collaborations, which are with people that are far better than you. And the final piece is don't try and keep up with everything. Like, don't. In fact, choose one subject area and master it. This is a craft. I think that it is important early on, once you've mastered one, to dabble in other subfields. So, for example, my research spans robustness, interpretability, fairness, compactness. And I think that's a strength because it unlocks different insights when I work in each. That's actually not typical for most researchers who are at Brain. Normally, they're much more specialized. But typically, what I've found is that people who dabble a little bit tend to see things in the long run that allow them to have insights which connect fields or unlock new ideas. Whereas the people who specialize a lot tend to produce more research, but it's within a narrow scope. So that is more of a personal preference, but definitely you shouldn't be going everywhere. You should have a thesis about what you want to achieve with your research and start somewhere. And often you can even start by reaching out to someone you admire and saying, hey, I just want to experience research. Do you have a research project you need help with? Because really, the most important thing is to get started on a narrow scope and not to be going from this course to that course or trying to keep up with everything. That's not how you should, it will drive you crazy. There's too much, there's too many things to keep up with. And in fact, your main goal should be exercising the full iteration of a project from conception to implementation to presenting your results. Even if those results are not a success, it's part of the experience of gaining machine learning experience and research experience.
Yeah, that's a valuable piece, because yeah, I could completely resonate on that, because most of the research work is much more concerned in exploring the depth of a particular domain rather than the breadth. So it really pays out if you are focused on a particular problem enough to explore the depth. So yeah, that's a very nice piece of advice. That's all I had for this particular podcast.
That was
I
plenty. That was really fun. Thank you so much for inviting me.
Yeah, thank you so much for answering these questions. I hope if people would have any questions, they would reach out directly to you. I'll leave a link to your website and also to your LinkedIn, so that people can reach out with any specific questions. But again, thanks a lot for being here, and I hope it was fun.
Absolutely. It was very fun. So thanks for inviting me.